Rationalizing denominators. What that means is we don't want radicals in the denominator of a fraction. There's two ways of doing this, two main ways. We're only going to deal with square roots, by the way. So if the denominator is a single square root, we're going to multiply by that single square root. If it's a binomial, the denominator is a binomial, we're going to multiply by something called the conjugate. This is the most important thing right here. The conjugate of a plus square root of b is the same thing except they change the middle sign. Let's keep that in mind. Just change the middle sign. And the reason why these work is for the following reasons. We'll do a couple of examples. Keep in mind, when we multiply by the same square root or by the conjugate, the whole idea is to not have any square roots. That's the whole thing. How to get rid of radical signs. For example, if you take the square root of 3 times the square root of 3, that's the same as square root of 3 times 3, which is the same as square root of 9. Square root of 9 is 3. In fact, if you take any number, any square root times itself, you're always going to get that number back, or that radicand back. So if you were to take the square root of 7 times the square root of 7, you get the square root of 49, which happens to be 7 also. It always happens that way. That's why you use that. That's why you use the same thing times itself. You always end up with a number with no radicals. Now if you take a number times its conjugate, or binomial times its conjugate, same thing is going to happen. Let's do the full method. Square root of 5 times square root of 5 is square root of 25, which is 5. And square root of 5 times negative square root of 7 is negative square root of 35. And then a positive square root of 7 times a positive square root of 5 is a positive square root of 35. And by the way, those cancel out because they're opposites. And then the square root of 7 times the negative square root of 7 is negative 7. So all that remains is 5 minus 7, which is negative 2. The important thing is no square roots. That's what we're going to be doing. Here we go. Let's rationalize the denominator. We're going to once again assume all variables represent positive real numbers, which means we don't have to worry about absolute values. First example, we have a regular old square root of 3 on the bottom. We don't want the square root in the bottom, so we're going to multiply it by itself, which is square root of 3. When you're dealing with fractions, the rule is what you do to the bottom, do to the top. So we're going to multiply the top by square root of 3 also. When we do that, I always do the bottom part first, just to make sure we don't have any square roots. What's square root of 3 times square root of 3? That's square root of 9. What's square root of 9? 3. And the top, 4 times square root of 3 is 4 square root of 3, and we're done. That's all we're doing. We're actually just transforming the appearance of our fraction. We're having a fraction with no radicals in the denominator. Let's look at this one, B part. You'll notice first off all kinds of things simplified, so let's go ahead and simplify those. First thing, square root of 16 is the same as 4. On the bottom, square root of 25, the 25 comes out as a 5, and the x stays. Now watch this, I can go on further before I even deal with rationalizing anything. That 5 goes into 10 2 times, and 2 times 4 is 8 on top, and we still have the square root of x on the bottom. Now we finally get to rationalize. So we have a single square root of x on the bottom, so we're going to multiply by that square root of x, top and bottom. And on the bottom, square root of x times square root of x is the same as square root of x squared, which is the same as x. And 8 times square root of x is what it is, 8 square root of x. And once again, if you want to see the step underneath, square root of x times square root of x is the same as square root of x squared. And that 2 cancels that 2. And it leaves the x, in case you're wondering. But that's what's going on when you're dealing with variables. Let's do a few more. Look at this one. Square root of 3x over 2w. The first thing you might want to do is rewrite it as square root of 3x over the square root of 2w. Now we're going to multiply top and bottom. Since nothing simplifies, we're going to multiply the bottom by itself, square root of 2w. And multiply the top by the same thing, square root of 2w. Do the bottom part first. Square root of 2w times square root of 2w. The more that you do of these, you're going to realize that that equals the radicand, 2w. The reason being is because that's the same as square root of 4w squared. The 4 comes out as a 2, and the square root of w squared is w. Now, on top, the square root of 3x times square root of 2w is the square root of 3x times 2w. And 3 times 2 is 6. And x times w is xw with the square root. So final answer is square root of 6xw over 2w. Now, you'll notice on D part, it doesn't have a single term. It actually has a binomial. This is where we start using the conjugate of the denominator. The conjugate is, for 1 minus square root of 3, it's 1 plus square root of 3. And once you do the bottom, you gotta do to the top. So we're going to multiply the top by 1 plus square root of 3 also. Once again, I always do the bottom part first. I'm not going to leave out any steps. I'm going to full the bottom. 1 times 1 is 1. 1 times the square root of 3 is square root of 3. Don't forget the plus sign. Negative square root of 3 times 1 is negative square root of 3. And negative square root of 3 times the positive square root of 3 is negative square root of 9. I already know what that is. That's a 3 because I've done these enough now. I'm going to stay at the bottom. These square roots of 3's cancel, which is what we were hoping to happen. We needed those to happen. Needed that to happen. We have 1 minus square root of 9 is 3. And you'll notice no square root. That's what we're hoping for. And 1 minus 3 is negative 2. So we know our denominator will not have a square root on the bottom. Now we're going to take the 8 and we're going to go ahead and distribute that. Or maybe we're not. Well, we're going to go ahead and distribute it. We'll get 8 plus 8 square root of 3. We're going to keep on bringing that down. And I left off my 8s. It's always a bad thing. You leave something off. Now, don't know if the system will accept that or not. More than likely it won't. So what we're going to do is we're going to take that negative 2 and we're going to divide it into each one of these 8s. So we're going to rewrite it as 8 over negative 2 plus 8 square root of 3 over negative 2. Because we can always separate numerators. And 8 over negative 2 is negative 4. So we end up with negative 4 minus 4 square root of 3, because we're just simplifying. 2 goes in 8 4 times. 2 goes in 8 4 times. Probably want to make sure you do that. Don't think the system will accept that, but you never know. Safe, better be safe. We got a couple more to do. Hopefully nothing as far as simplifying will happen, but hey, if it does, it does. Once again, don't want any radicals in our denominator, so we're going to multiply by the conjugate of the denominator. In this case, square root of 11 minus square root of 7. What you do to the bottom, you got to do to the top. And hopefully the more of these that you do, you'll start noticing some shortcuts. Full method. Square root of 11 times square root of 11 is 11. Square root of 11 times negative 7 is negative square root of 77. Plus square root of 7 times square root of 11 is the positive square root of 77. And square root of 7 times the negative square root of 7 is negative 7. These square root of 77's cancel. And it leaves 11 minus 7, which is 4 on the bottom. Now on the top, we're going to multiply it out, like we normally do with the full method. Square root of 5 times square root of 11 is the square root of 55. Square root of 5 times the negative square root of 7 is the negative square root of 35. Square root of 2 times square root of 11 is negative square root of 22. The negative times the negative is a positive. Square root of 2 times square root of 7 is a positive square root of 14. Looking right quickly, nothing can be simplified, so our numerator stays as we have it. So our final answer is the square root of 55 minus square root of 35 minus the square root of 22 plus the square root of 14 all over 4. Is that fun or what? Probably said what just then. Let's do this next one. A over square root of b minus square root of c. Once again, we're going to multiply by the conjugate of the denominator, which is the square root of b plus the square root of c. And once you do the bottom, you do to the top. I'm going to use this one to show you some major shortcuts. Anytime you multiply by the conjugate, all you're really doing is taking the square root of b times the square root of b, the first terms, and you get b. The outers and inners will cancel out every single time. Then you multiply the last terms. In this case, negative square root of c times the positive square root of c, and you get minus c. And then you full the top out, or distribute the top I should say. You get a square root of b plus a square root of c, and you're done. Nothing reduces, simplifies. We are done with this problem.